Hello, Advanced Math. We are here today to write expressions with unknown numbers from word problems. Please mark this in your math notebook as on the next blank page with the title. And after you have done that, put your pencil in your math notebook until we get to the we do. Just think and listen until then. So yesterday we wrote expressions that involve letters from things like this: 4 more than, 6 times a number. And we talked about how a number, an unknown number, we represented that with a letter since we didn't know it. So this a number that we don't know could be whatever letter you want it to be. A lot of times we do something like this. It starts with N, so we use an N. And what I would do, I say I want 4 more than, 6 times a number tells me I would multiply that number by 6. 6 times another number, and 4 more than it means after I know this, multiply first, then I would add to it 4 more. And so we wrote expressions like that yesterday. We're going to do the same today, but we're going to do it from full-on word problems. All right, so let's look at this situation here. We're going to write an expression from this. So to attend the fair, it costs Maya's family $4 for parking, plus each of her 6 family members must buy a ticket to enter. Write an expression that shows how much it will cost for the family to go to the fair. So let's list what we know here. $4 for parking. Six family members. They only have to buy the parking once because they can all go together. But each family member must buy a ticket to enter, and we're looking for the cost to go to the fair. So I need to add together the cost of the parking plus the cost of the tickets, if that makes sense. That's going to show me, I'm just going to write in words here, that's how much they're going to pay all together to go, the cost of the parking plus the cost of the tickets. So I know how much it costs to park. I do not know the cost of the tickets, right? I know they're going to have to buy 6 tickets, but I don't know how much the tickets cost. So what I'm going to assume is I've got an unknown value there, right? How much the tickets cost. So I'm going to pick T for tickets and just say that T is the price of a ticket. I don't know that value. That's an unknown in this problem. So I know that the cost of the tickets is going to be 6 times whatever that T value is to get in there. Whatever this is, whatever this cost is, if it's $5, if it's $10, I don't know. I'm going to have to multiply it by 6 to buy 6 of them. Remember, this is 6 times T if you don't write a sign there. We talked about that yesterday. So the expression that's going to show their total cost is going to be $4 to park plus 6 times whatever that ticket is. And if I then knew the ticket cost, then I would be able to calculate the price. But without knowing it, this is an expression that shows me how much they're going to pay when I don't know a certain value. I can't just give them a price because I got to know the number. All right, and I got that, by the way. That was a real situation that could go with this problem we just talked about. 6 times the ticket plus the 4 to park. Same thing, but rather than just a quick sentence, that shows what like a real problem where this exact expression might be useful. And if you rewrote this as 6 times the tickets plus 4 to park, that would be fine too. Doesn't make any difference. Thanks to the commutative property, I can add 2 things in any order that I want. Doesn't matter. Okay? Open up your math notebook and let's do the we do together. So to train for a race, Lenny's going to run 5 laps around the perimeter of his town. The town is rectangular. It is 1 7/10 miles long, and he does not know how wide it is. Write an expression that will show how far Lenny will run. Oof, complicated situation here. I'm going to draw something out. So Lenny lives in town here. The town's rectangular. It is 1 7/10 miles long. He does not know how wide it is. Now, as I've drawn this, it makes it look like we know that the width is shorter than the length. I don't know that either. It might look like this for all I know. But the width is unknown. So he's going to run around the perimeter of his town 5 times. 1, 2, 3, 4, 5. So he's going to do this, and he's going to do this. And he's going to do that 5 times. So he's going to run loops around this town. I just want to make sure I understand the situation before I try to write an expression for it. So the way I would write this expression is I would say, well, he's going to do, let's just say he starts here. He'll run 1 7/10 miles plus the width, I don't know it, plus 1 7/10 miles plus the width. And that's 1 lap. So Lenny's going to do that, but he's going to do all of that 5 times. He's not just going to do that once, he's going to do it 5 times. I don't want to just keep writing this 5 times. So what I'm going to say is I want to take all of that whole thing, and I want to multiply that by 5. So I'm going to add up this and this and this and this, and then I'm going to multiply it by 5. You could also do the multiply 5 at the beginning. Typically, you'll more often, when you multiply parentheses by something, you'll usually see mathematician types write it at the beginning. So that works too. Remember, this means times now. And actually, remember you don't need any sign to multiply, so you could also write it like this. But those are 3 different ways to represent Lenny's run, because he's going to do that plus that plus that plus that, that plus that plus that plus that, and then he's going to do it 5 times, and that's how far he'll run. If we knew how long the width was, we could calculate his run, but since we don't, we just have to leave it as an unknown W value. That's it. That's how you write an expression with an unknown value in a word problem. After you've written this one down in your math notebook, if you need to go back and look at either the I do or the we do again to feel more comfortable, you may do so. If you feel like you've got the hang of it, I will see you tomorrow.